Namaste. Hope you are doing well. Today we will solve the 21st question of ISI MSTAT 2024 PSA. And honestly, this should have been a PSB question. This could have been a PSB question. Just give the same setup and ask to prove all these things, that you have the joint distribution which is uniformly distributed in a particular region, and you are given some statements, prove them. But instead, we are being asked the statements that are given, how much true they are. The four options correspond to identifying how true the statements are. So let's get started. Now, the first step obviously is to be able to visualize this graphically so that it may be able to be solved easily, because we see the word parallelogram. There's some change to that graphical visualization. And indeed, we can have the graphical visualization quickly by looking at the 4 points. There is something which is symmetric about 0, or at least looks symmetric about 0. And from there we can proceed. And from this we can also have an idea about the actual joint distribution PDF, how that can be written. And if you are fixing X first and then conditioning Y on X, we could define the region to be X taking values from -2 to 2. And for whatever value X takes, say for instance, X is 0, then the range of values that Y can take is given by these conditions. And how do you find these conditions? You can look at 3 edge cases, something like X being 0, what is the value that Y can take? X being -2, then what is the value that Y can take? And X being +2, what is the value that Y can take? And looking at this, you could come up with this kind of linear condition. And other way to represent it is to fix Y first and then condition on X. So when Y is taking values between -1 and 1, and whenever Y is fixed, we see that this is easier when Y is fixed, because X seems to be varying in an easily understandable way, which is from Y -1 to Y +1. Now with this, can we build some intuition about the options? And yes, we can. Even though it may be difficult to say about the marginal distribution of X, we can see that this area, these 4 areas over here, if you multiply XY over here, there's something positive. If you multiply XY over here, there's something positive. In these 2 areas, XY are negative. But we see that the bulk of the product of XY is positive. It's visibly interpretable. And that's why this expectation has to be greater than 0. Now, the argument on independence can be easily disproved by looking at the conditional distribution, that when Y is fixed as 1, X is constrained to take only these values. But when Y is fixed as -1, X is constrained to take these values. So clearly it's not independent. And in exam, all we would have to do was just find the marginal of X and we'd be done, because intuitively it is quite clear. So we shouldn't be bothering finding the answer for this in a rigorous way, but because it's a video on YouTube, it will be done. So the way you find the marginal of X is integrate the joint PDF with respect to Y. So you would be using this kind of structure. And the main thing is actually just coming up with the limits, and after that the integration is pretty straightforward for this value range and this value range. And how you determine this range is also determined by the limits. So you see, you are given the lower limit as -1, maximum of -1 and X -1. So this sort of has this breaking point at X equal to 0, right? Because when X is equal to 0, -1 is neither less than nor greater than X -1. It's the same as X -1. And even in this case, the breaking point is X equal to 0. So this is how you build the intuition for splitting how the integration is going to be done for different range of values for x. And then the marginal is clearly not uniform. And so none of the options are, that's it. But in order to make things more formal, you can also compute the expectation of x and y with the standard formula. And because this path is easier, you can go this route, and you eventually end up finding the expectation as well to be 1/3. And x given y is uniform, but x is marginally not uniform at all. So hence x does depend on y. And that's why we see that none of the options are true. And some ways to build your base for exams is symmetry may show up in your problem, but not in the way you expected. Because in this case, we did see that this parallelogram was a nice symmetric structure. So at the first glance, this thing might have seemed true, but it was not when you introspect it further. The structure was indeed symmetric, but we had to be careful about the expectation. So that's it. And if you like this, then the powerful request this time is to build intuition to perceive symmetry better. Because many times you may be deceived by the perception of asymmetry. So take care. Hare Krishna.